Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of linear functions, specifically how we can write them, given either a scatter plot or just a set of coordinates, and we'll do it in 5 minutes or less. So we spent a lot of time in Algebra 1 taking a linear function and then putting it onto a graph, but now we're going to do the opposite. And sometimes you'll be given just a scatter plot like we see on the left, sometimes you'll be given the full list of coordinates on the right, sometimes you'll get both. So let me show you how to turn both of these into a linear function. And just in case you're wondering, the coordinates right here represent every point on the graph. So it's not two separate things, it's just one. So let's start with the graph. Well, this is a scatter plot, so we are going to try to find a line of best fit. It's not going to be perfect. We're going to get about as close as we can there. So that's about our line of best fit. It tries to navigate a straight line through all of your points here. Now, what do we notice about this? Well, it needs to be in our slope-intercept form. That's how we're going to write our linear function, and we've already got that first part right there. So my line was about, looks like my y-intercept is going to be about 10. So let's say y equals, and I'm going to say this is a negative slope, because we know that it is going down. And so when we're going down, right, from left to right, it is a negative slope. So I wrote negative mx plus 10. All we need to do is figure out what that slope is. And none of the points on the scatter plot are actually on the line. So what I'm going to do is I'm just going to take a few points that look like they're right at whole numbers right there. And I'm just going to kind of see what they are. So let's see what those two are right there. Okay, so that is, let me see, 6, 8, and this is 16. It looks like that is just 4. Okay, so let's see what we've got here. Remember, our equation for slope is going to be y2 minus y1 is change in y over x2 minus x1, right? And so we're going to say 4 minus 8 over 16 minus 6. So it's about negative 4 over 10. So it looks like we're at about negative 4/10, negative 2/5. So really about negative 0.4. All right, so if we wanted to, we can say this is about negative 0.4x plus 10. At least that's what it looks like when we're given a graph. What happens if we're just given points here? Well, what we could do is we can take several points here, and we can just do the same thing, right? y1, y2, but you want to take kind of a good mix of them, right? So let's see, I've got these 2 points, so 1 minus 5. We're just looking for the slope right now, and that's 24 minus 15, so that's going to be negative 4 over 9. Okay, so negative 4/9. We'll leave it just as a fraction right there. And then let's take our most extreme number. So it looks like our x is going to be our biggest one if we want to make our x1 right here and our y1 right here. And then our x2 right here and our y2 right here. We're just looking to see if we can find any patterns here. So this is going to be y1 is, or y2 is 8 minus 1 over, and then x2 is 1 minus 32. So now we're going to get 7 with a negative 31. So what we could do is we can keep doing a few of these, and we can see kind of what our average is here. But if we just kind of plug these in, this is negative 0.44, and this is negative 0.22, and you notice how that kind of falls in between. So if I just took these, I might say, oh, negative 0.33 kind of lands in the middle. Y equals negative 0.33x plus 10. So you see how we are close.